Today our topic is factoring trinomials. And we're going to set up our paper Cornell style. So I'm going to take off some of my left-hand side for questions. Alright, so before we get started, let's recall what a trinomial is. So in our last lesson we were multiplying binomials. So let's look at that. We had something like x plus 2, the quantity x plus 2, times the quantity of x plus 5. And we used FOIL to multiply these. So first, outer, inner, last. And then we combined our like terms here and came up with x squared plus 7x plus 10. This is a trinomial. Trinomial because there's 1, 2, 3 terms, and nomial means term. So we have a trinomial here. Today we're going backwards, just like we started out with multiplying and distributing, and then we went to factoring. Today we're factoring, which means we're going to start with something that looks like this, a trinomial, and we're going to turn it into the product of two binomials. How we do this, and we're going to use this as an example just so we can see if we get it right, is we take the number in front of x squared and the constant term, which is the term at the end, and we multiply those two numbers together and we get 10. So we're going to make a factor sum table. Factors and sums. What we have the factors of 1 times 10, so factors of 10. Well, when I factor 10, the things that multiply together to give me 10, I get 1 times 10, 2 times 5. And then there's also negative cases, which we don't have to go and list all of the factors. As soon as we find the correct sum, we can stop. Then over here in my sum, I'm going to add those two things together. And I get 11, 7, negative 11, and negative 7. What we're trying to get a sum of is this middle term, the thing connected to my x. So if I look in my table, my factors 2 and 5, positive, give me a sum of 7, which is what I want. So I simply write my parentheses for my binomials, and then I'm going to have x plus 2 times x plus 5. And so we have factored the trinomial. And we're going to look at several examples of this. So first example, and remember to write any questions that you have over here on the left-hand side, and then we can answer them when we do our examples in class. Let's look at b squared plus 21b plus 20. And I need to know what I need the factors of. And so remember, if there's no number in front of my b squared, there's a 1 there. So I'm multiplying these two red numbers together, 1 and positive 20. So I need factors of 20. And what I'm trying to get those factors to add up to is 21. So if I factor 20, I have 1 times 21, 4 times 5. We have our negative cases, or 1 times 20, sorry. We have our negative cases, but let's if we factor and sum at the same time, we'll see if we can cut our work down a little bit. 1 plus 20 is 21, and this is already the factor that we want. Just to complete this table, 4 plus 5 is 9. So I'm going to use 1 and 20, and when I write my parentheses for my binomial, and then I have v plus 1 and v plus 20. Next example, a squared plus 13a plus 30. I have a 1 in front of my a squared and a positive 30 at the end of my trinomial, and so I'm trying to have a factors for 30 times 1, which is 30. And when I sum the factors together, I'm looking to get a 13. So let's begin with our factors. 1 times 30, and then I'm going to sum at the same time. That would be 31. 2 times 15. If I sum these together, I get 17. 3 times 10. If I sum these, I get 13, and that's what we're looking for. So I'm going to write my parentheses for my binomials, and I'm going to have a plus 3 times a plus 10. And if I notice something about these terms in these examples, all of them were positive. Let's look at something with a negative. Let's look at k squared minus 10k plus 25. So the factors here will be for 1 times positive 25. So I need factors for 25 that create a sum of negative 10. So now I know that I need positives and negatives when I'm factoring. And here's my sum. Okay, so we've got 1 times 25. If I sum these, that's 26, way too high. I have 5 times 5, and if I sum these, I get 10. And I need 10, but I need a negative 10. So I'm going to put a negative in front of these, because if I multiply negative 5 times negative 5, I get a positive 25. But when I add these together, I get a negative 10. So we're going to use negative 5 and negative 5. I'm going to write my parentheses for my binomials, and I'm going to have k minus 5 times k minus 5. Next example, let's look at x squared minus 11x plus 18. Remembering that there is a 1 in front of my x squared, I'm going to multiply 1 times positive 18, and so we need to find the factors for positive 18, which create a sum of negative 11. I always start with 1 times the number, so 1 times 18. If I sum these together, I get a 19. That's way too high. And then I have 2 times 9, If I sum these, I get 11, and I need 11, but I need negative 11, so I'm going to see if this works out. Negative 2 times negative 9. When I sum these together, I get a negative 11, and when I multiply them, I get a positive 18. So we're going to use negative 2 and negative 9. Open my parentheses for my two binomials, and I have x minus 2 times x minus 9. Example 5. Let's look at m squared plus 8m minus 20. So looking at the number in front of my m squared and my constant at the end, I multiply these two together and I need factors for negative 20, which give me a sum of positive 8. So for negative 20, and if my product is negative, I know that my signs have to be opposite because a negative times a positive will give me a negative. So I don't need to worry about positive cases, all positive or all negative. I'm going to have flipped signs here. So let's look at 1 times negative 20. That would be negative 19, really high. Let's look at 2 times negative 10. When I sum these, I get negative 8. So this tells me since I got a negative and I need a positive, that I put the negative on the wrong number here. So let's try negative 2 times positive 10, and that will give me a positive 8. So we're going to use these factors. I'm going to open up my parentheses for my binomials, and I'm going to have m minus 2 times m plus 10. Last example. And remember, when you're watching these videos, it's better to watch me do the example and then to pause and to copy the example. Let's look at p squared minus 3p minus 40. So if I look at my number in front of p squared and my constant at the end, I'm going to need factors for 1 times negative 40, which is negative 40. And I need a sum of negative 3. Once again, if I have a product that's negative, my signs are going to need to be opposite. Just using my integer knowledge there. Alright, so let's look at negative 40 times 1. If I sum this, I get negative 39. That's way too high. 2 times 20. I'm just going to start with negatives in the front. If I sum these, I get 18. It's still way too high. Let's look at 4 times 10. If I sum these, I get a 6, which is getting closer. And 5 times 8. If I have negative 5 times 8, I can sum these up to get a positive 3. And so what this tells me, since I need a negative, is that I need to flip the signs. And there's a negative 3. So sometimes it takes us longer to find the factors, and that's fine. I'm going to open up my parentheses for my binomials. And I'm going to have p plus 5 times p minus 8. When you get to class, I have 5 examples ready for us, so let's write these examples down. X squared plus 7x plus 12. and d squared minus 17d plus 42 3q squared minus 15q plus 36 m squared plus 6m minus 27. And factoring is important, so we'll do 5 examples this time. Y squared minus y minus 56. These are the examples we'll do when you come into class, so be prepared to do that. And I'm going to give you a question for your left-hand side today. Remember to put any of your own questions, but a really good question would be, what if the factor table does not give us the sum we need? That's an excellent question. Maybe if you look through your book, you can find the answer to that, and then when you come into class, you can help us answer that.